For our last dividing fractions with models video, we'll be looking at how to divide a fraction by a fraction. Our first example has to do with brownies again. There are 3/4 of a brownie. A serving is 1/2 of a brownie. How many servings are there in all? Another way to think about this is to write our equation, which is 3/4 divided by 1/2. We want to know how many 1/2s there are in 3/4. So how many 1/2s fit in 3/4? So the first thing I'm going to do is divide my top bar into fourths. And since I have 3/4, I will shade 3 out of the 4. My second step is to divide the bottom box into halves, since that's my next fraction. And then I want to look at how many 1/2s are in 3/4. So this is representing 1/2 and this is representing 1/2. So I clearly have 1/1/2. And over here, I don't exactly have 2 full halves. It looks like I have half of a half. So I have half, I have one of the 2 pieces I need to make a full second half. So my answer would be I have 1 out of the 2 that I need. So my answer is 1 whole and half of a half. So again, how many halves are in 3/4? 1 and 1/2. Let's look at another example. There are 3/4 of a brownie. A serving is 5/8 of a brownie. How many servings are there in all? So remember, our equation will be 3/4 divided by 5/8. And we want to find out how many 5/8 are in 3/4. So our first step is to divide the top box into fourths. And then we will shade 3 of those fourths. Our second step is to divide the bottom box into eighths. And now I'm looking for 5/8. So how many groups of 5/8 are in our second box? So I have 1, 2, 3, 4, 5. So this makes 1 group of 5/8, and then I have 1 left. So this represents 1 group of 5/8. And then I have 1 left over. I have 1 out of the 5 that I'm looking for. So my final answer is 1 full group of 5/8 and then 1/5 left over. So 1 and 1/5 would be my answer. This example is a little bit different. I have 3/4 divided by 1/3. So I want to know how many 1/3s go into 3/4. If I divide my top box into fourths, shade 3, now I need to divide my second box into thirds. And what you see is that our lines of dividing the boxes are not equal, as they were when we were dividing in the previous 2 problems. The reason for that is our denominators do not equally divide into each other. And so when that is the case, we cannot use this model. We have to use a different model to show the division of fractions. So this is a second way to model division of fractions. This is very similar to how we drew multiplying fractions. So we're going to look at the denominators of both of our fractions and make an array. So I'm going to divide our first box vertically into fourths. And I'm going to shade 3 of those. And then I'm going to divide it in the opposite direction, so horizontally into thirds. And on my second box, I'm going to do the same thing, except I'm going to start with the thirds first. Because this box is representing 1/3. But I also want it to show the fourths. And now what we want to do is count how many shaded boxes there are in each of the arrays. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And on this one we have 4. And so now we have 9 divided by 4. And if you guys remember from our previous unit, 9 divided by 4 can be written like this as a fraction. And so that is actually the answer to our problem. And then we can simplify that into a mixed number, and it would be 2 1/4. Okay, this will be our last example. We have 2/7 divided by 3/5. Again, 7 and 5 do not divide evenly, so we need to use the area model. So each box should be an array of a 7 by 5. So starting with 2/7, I'm going to cut my box into 7s. And I'm going to shade 2 of those 7s. And then I'm going to cut it vertically the other direction into 5ths. Okay, on my second box, I'm going to start vertically with 5ths, same as my first box, and shade 3 of those. And then horizontally, I will divide it into 7ths. And now I'm going to count how many boxes in each array are colored. So in my first one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In my second one, I have 1, 2, 3, 4, 5, 6, 7. So 7 in each row would be 14, 21. So it looks like my fraction here is 10 over 21. So you have 3 questions to solve on your own. Before you do, I want you to take a look at the denominators of each problem to determine if you can use the fraction bars or if you have to use the box arrays. So for the first question, your denominators are 3 and 6. Those divide evenly into each other, so you can use the fraction bars. The second one, 8 and 2, those also divide evenly, so you can use the fraction bars again. Of course, if you want to use the arrays for those, you can also do that. And the last one, 8 and 12, they do not divide evenly into each other, so you need to use the box arrays for the last question.